In this lesson, we're going to take a step further than a triangle and start looking at some polygons and how the angles inside them works. The cool kind of thing is they actually relate back to triangles. In fact, if you redraw your polygon, which is just a multi-sided figure, as a series of triangles, you'll probably notice a pattern. So we'll start with a simple shape, the triangle. What do we know about it? Well, we know, based on yesterday, well, obviously it's one triangle, but the angles inside make 180. It turns out that for any four-sided figure, you could divide it in half, creating one triangle, two triangles, and each of those is worth 180. So a four-sided figure actually adds up to 360 degrees for the angles. And the same is true for any other polygon. If I divide this into a series of triangles, I'll pick one starting point and get one triangle, two triangles, three triangles, and I times it by 180 for each of the triangles, so 180 plus 180 plus 180, just faster to multiply it, I can get the sum of the inside of any triangle. So a five-sided figure, a six-sided figure actually makes four triangles, which is 720. A five-sided figure, a seven-sided figure makes 1, 2, 3, 4, 5 triangles. There's a bit of a pattern here too. If you stop and actually look back at the things we've just done, I don't even have to draw the triangles if I think about how many sides the shape has. This was a seven-sided shape. It had 5 triangles. This was a six-sided shape. It had 4 triangles. A five-sided shape has 3 triangles. There's a pattern here too. If I count the number of sides I have and subtract 2, I always get how many triangles I have. Since I know that each triangle is 180 degrees, I can basically create a formula that allows me to do this regardless of how many sides I have, and do it in a fast way. So here's our big rule. For a polygon with n sides, so count how many sides you have. Doesn't matter what number you have, you can always subtract 2 and then times it by 180, and you'll know the sum of all of the sides, or all of the angles. So for instance, determine the sum of the interior angles of the shapes with the number of given sides. If I had a 14-side figure, that'd be hard to draw, much less break into triangles. But I don't really need to do that. If I subtract 2, I'll get 12 triangles. What do I know about each triangle? I know they're each worth 180 degrees. So if I take 12 of them and times by 180, the whole angle inside this 14-sided shape has to be 2,160 degrees. Okay. What if we had a 25-sided shape? Subtract 2, I get 23 triangles. Each triangle is worth 180 degrees. That means this entire shape, if I could possibly draw it out, would have angles that add up to 4,140 degrees. But who'd want to draw that, right? That'd be hard to draw, much as break into triangles. Why do I like this idea? Well, the reason I like this idea is I can figure out missing angles in multi-sided shapes. Knowing about how many sides the shape has allows me to figure out how many angles the shape has. So, let's give one of these things a try. I've got a 4-sided shape. If I take my 4 sides and subtract 2, I get 2. 2 triangles. Each triangle is worth 180. This shape has to add up to 360 degrees. If I know 1, 2, 3 of the 4 angles, I can figure out A by taking my 360, that's what the whole thing is, and subtracting the parts and pieces I already have. Whatever's left over has to be the missing angle to make it add up. Try the next one. What do I know about the next one? Ooh, a 4-sided shape again, with some lines sticking off the end of it. Hey, I know something about lines. We talked yesterday, if I have a straight line and it gets met, I can figure out the 2 parts of it because they add up to 180. So B has to be 180 take away 129, or in other words, 51. Same thing for A. There's a straight line. A has to be 180. Take away 76. It's got to be 104. How could I get the other angles? Well, I know something with this one, a box. Hey, that's 90. What do I notice about my diagram now? I notice that I got a four-sided shape, 1, 2, 3, 4, which from over here I'm going to cheat, is 360 degrees. And I know one angle, two angles, three angles. I could figure out the fourth one by taking 360 and subtracting the parts and pieces I already know. Whatever's left over has to be the remaining angle. In this case, it should come out to 115 with my calculator. Let's take a look at C here. Ooh, it's a messy looking shape. How many sides does this have? 1, 2, 3, 4, 5. 5 sides. Well, if I take my sides and I subtract 2, I get 3 triangles. 3 times 180 makes 540 degrees altogether. What do I know about the insides? I know 1, 2, 3, 4 of the 5, which means I can solve for the fifth. I take the whole thing, 540, and subtract the parts and pieces I already know. So I know 4 of the 5. Whatever's left over has to be the missing angle. In this case, I got 51 with my calculator. Okay, so it's kind of like the idea yesterday where I had triangles and we knew they add up to 180. Or I could take outside things to get inside things. I can do that here with polygons just by figuring out how much the whole thing has to add up to first. And what other kind of questions can we solve? Given the diagram below, determine the sum of the interior angles. So fancy math words. In other words, what does the inside add up to? Well, I know how to do that by counting my sides. 1, 2, 3, 4, 5, 6. Okay, 6 sides. Take away 2 is 4. 4 times 180, that's my triangle work, is 720. So the whole thing has to be 720 degrees. Part B. What is the measure of each angle in the polygon? Well, how could I figure that out? If I look at these angles, what's true about them? Well, if the polygon has all the same sides, that means the angles all have to be the same. So I can take my 720 and divide it evenly by 1, 2, 3, 4, 5, 6. If I do that, I can figure out each angle on sides 120. And what part C determines the value of each exterior angle of the polygon? Well, an exterior angle is an angle on the outside. In other words, it's these ones.
Mr. Jones, please call extension 3304. Mr. Jones, call 3304.
How can I get any of those angles? Well, let's take a look here. We've got a straight line being met by another line. If I know that the inside angle is 120, can't I figure out the outside angle? For sure. Outside angles have to be 180, my straight line, take away the inside part. So each outside has to be 60. 60 and 60 and 60 and 60 and 60. It didn't matter which pair I picked, they all have to be the same. In fact, part D determines the sum of the exterior angles. Well, there's each of them 60, and there are 1, 2, 3, 4, 5, 6 of them, and that comes out to 360 degrees, which should make sense. What shape do we create if we go all the way around the outside? Hey, it's a circle, and circles are 360 degrees. So I don't actually need any numbers. If I know something about the shape, how many sides it has, how many angles it has, I can problem solve with them. We didn't have any numbers to begin with, we just had to think about this one. So let's try a couple of these real quick. Find the unknown angles. What do we see? We see 1, 2, 3, 4, 5 sides. 5 minus 2 makes 3 triangles. Each triangle is 180 degrees, so I get 540. If I want the inside angles, I take 540 and I divide by 5. There's 5 of them. That gives me 108. That's the inside angles. We don't want the inside one, we want the outside one, which is along this line. What do we know about lines? We know that lines are 180. Take away the part we already have. Yeah. Each outside angle has to be 72. Okay, you gotta try the last one, pause it, see if you get it right. Here we got 1, 2, 3, 4, 5, 6, 7, 8 angles, or sorry, 8 sides, which makes 6 triangles, which makes that 1080 altogether. How many angles do we have? Well, if we count them up, there's 8 of them. So 1080 divided by 8 will give us the inside one, which happens to be letter Y. And you get 135 for that. And these are actually all the letter Y, right? Because they're all the same. Well, that means I can get X. X must be 180, take away 135, or in other words, 45 degrees. Okay. So our objective today is to figure out angles inside polygons. Our big trick is remembering this formula. Count your sides, subtract 2, to figure out how many triangles you have, times by 180, and you'll always know the sum of your angles. After that, it's just the same ideas as previous, inside and outside lines. Right, give this sheet a try. If you're stuck with things, come see me. And tomorrow we're going to move on to the last sort of big idea for angles.